Alright, in this video we're going to continue on a little bit with numbers. As a recap, if you watched the first video, I explained the number line and that we do have negative and positive numbers, and that this number line represents all the numbers that are in the domain of real numbers. And all the numbers could be split into half, where half are the real numbers, the other are the imaginary. We're not going to be dealing a lot with imaginary numbers. Maybe a touch on it in the extra class. All right. But for most of the calculations on any of the 3 amateur radio level tests, I don't think they deal with imaginary numbers. Okay, let's continue on. The next thing that I want to look at that deals with numbers is the number place. So let's take a value here. All right, this is a decimal number, and I left big spaces between them because I want to put labels here. This has to do with the weight of the values, the position that each number occupies. And this, of course, is the decimal point. So anything to the left of the decimal point is equal to 1 or more, and anything to the right of the decimal point is less than 1. So we would read this as, we have 6 numbers here, so we have 123,456. So let's deal with this side first. This is 100,000. This would be 10,000. This is 1,000. This is 100. This is the tens place, and this is the ones place. And if we carried on this way, which I probably should have done, because in electronics we get to really big numbers and really tiny numbers, but the next one would be, see, we have 100,000. Next one would be 1,000,000. So I could have something out here. I'll put a 3, and this would be like 3,000,000. 6 zeros. Okay. And then 10 million, 100 million, and then a billion. All right, on this side, we get to the 10th position, the 100th position. Notice that that goes basically like it is over here, except it's as a fraction down in the denominator. So this is 1/100th, and 1,000th, and 1/10,000. And of course this would go out even more. This would be 1/100,000. And we're matched up with the other side. So these positions determine the weight of each of the value. So if I had just this value, this would be 3,000. Okay. And if I had this value right here, I had 0.009, that would be 9 1,000ths. You got to lisp a little bit and get that TH in there. Okay. These also have some common names. This is the kilo for the metric prefixes. And this one is mega. They have a name every power of 3. So this would be milli, like millivolts, milliamps. And I don't have the million out there. That would be micro, 1 over 1 million. This is micro. And they go on from there. So let's see, maybe I can bring one of those in. Let's insert an image here. Okay. This gives you a better idea of, or at least puts them in table form for you. You can see as they go up here to 1 billion. So every power of 3. That's basically engineering notation in scientific notation. So the power here represents the number of zeros. And on the less than 1 side, it represents the number of places behind the decimal point. I've never seen centi used much, but certainly milli, micro, nano, and pico. Capacitors are measured in nanofarads and picofarads quite commonly. And then, of course, in frequency, megahertz, HF is all in the megahertz range. And then if you want to get into microwave or whatever, we're into gigahertz. And if you have a computer, you probably know that your microprocessor is running at 3 or 4 gigahertz. That's cycles per second. 3 billion cycles per second. That's a huge, unimaginable number. Talk about fast. Okay. And, of course, the designations for them. Since M is used for milli, they decide to use the Greek character mu, and it looks like this. I'm not writing for some reason. Well, it doesn't matter. You can see it here. The mu is like a U, except the leading line of it goes down a little further. That's called a mu. All right. I think that's enough for this. Gives you an idea. You should be familiar with these prefix names and what their values are. Okay, keep a table like this. I don't memorize stuff very well. And that caused me fits in grade school trying to remember the multiplication tables. But anyway, keep one handy in your lab notebook or your station notebook, whatever, so you know what they're talking about. And great. Okay. That's good. I'll see you in the next video.